Assalamu alaikum guys, I am here with another complicated question on this connected particles thing. The thing is, one of my student asked me to solve this question. Now the different thing in this question is that like what is different from my previous videos, what is special in this case, in this question, that is that while these particles are moving, being connected through a string, what happens is that there comes a stage when the string becomes slack. So you have to very carefully consider the situations differently. You can divide the whole situation in parts, like where the motion when the string is taut and the motion when the string is slack. So let's see what is in this question. It says particles P and Q of masses zero point 0.6 and 0.4 kg are attached to the ends of a light inextensible string. So let me start by showing that its mass is 0.6 kg. So I'll be showing its weight like 6 newtons, and its mass is 0.4 kg. So I'll be showing this as 4 Newton. Before I proceed with the question, we're given here sine theta is 0.8. Okay, now sine theta is given as 0.8. You know that 0.8 is actually 4 over 5. So remember that 3, 4, 5, the right angle triangle side. So you can easily say that the cos theta, then that would be 3 over 5, that is going to be 0.6. Now this is going to be used over here. Okay, so I'll be resolving this way like this. Now in this question it is given that these sloping surfaces, they are both smooth, so there is no need to know this r. I'm just going to show this. So this is 4, this is theta over here, this is 4 cos theta, and this one is going to be 4 sine theta. Okay, and for this one, for this P, I should be resolving it like this. This is theta over here, this is its r. Let me call this r1 and this is r2. Okay, now this is going to be 6 sine theta, and this one is going to be 6 cos theta. Okay, and obviously the tension has to be shown in the string, so which will be same. This is the tension T and this is the tension T over here. Okay, now the question says, okay, the particles are released and move along lines of this greatest slope. Find the tension in the string and the acceleration of the particles while both are moving. Now this should be very easy for you to find this. Particle P is heavier, so this would be going downwards, okay, and this is going to go up the slope. So if you look at this P, so its component of weight is 6 sine theta. So I'll be writing it as 6 into 0.8, which is the sine theta, minus T, that is equal to 0.6a. That is from the particle P. And then from the particle Q, this is going upwards. So upwards we have the tension T over here, this tension. Okay, so this is going to be T minus downward the weight component, that is 4 sine theta. You can see this is 4 sine theta over here. Okay, so this 4 and the sine theta is 0.8. So this is going to be T minus 4 into 0.8, that is equal to 0.4a. So by adding or subtracting these two equations, we can get the acceleration. I think that should be, if I do that mentally, these are cancelled. This is 6 minus 2 into 0.8 is going to be, I think this should be 1.8 meter per second square. And then you have the tension, that will be like putting that A into any of these equations. This, I'm putting that into the Q's equation. So this T is going to be 0.64 plus 3.2. So this looks to be 3.8 0.84. That is the tension in this. Let me check from the book. Yes, we have both our answers correct. Okay, now it says the speed of P when it reaches the ground is 2 meter per second. When this P reaches the ground over here, its speed over here is 2 meter per second. And remember, when we just released it, so that means its initial speed is going to be 0. On reaching the ground, P comes to rest and remains at rest. Q continues to move up the slope but does not reach the pulley. Find the time taken from the instant that the particles are released until Q reaches its greatest height above the ground. Okay, so this is the case where you have to see how long the string was taut and how long the string is slack. So we need to divide it into two situations, one where the string is taut and second where the string is slack. Okay, now as long as we consider this taut situation, the string will be taut until this P hits the ground. So let's see when this hits the ground how much distance has been covered, because the distance this goes down the slope would be the same as this is going to go up the slope over here. Okay, so we have the initial speed as 0, we have the final speed as 2, and we have the acceleration as 1.6. So we can find that distance, that is 2as, that is v square minus u square. So this is 2 into 1.6 into s. This is going to be 2 square, okay, and this is minus 0. So this s is going to be 4 over 2 into 1.6. This is 2's are, that's 20 over 16, 5 over 4, that is 1.25. So this has gone down 1.25 meters and this has gone up 1.25 meters. Okay, now what do you think that when this P has hit the ground, this Q has reached this level? So will this Q stop immediately or will it be going upwards? Obviously your answer is that this cannot stop immediately. This will continue its motion up this slope. Now when this is continuing this slope, this motion up the slope, the string is slack now. There is no more tension in the string. Okay, so we have determined that the string is slack. There is no more this upward force acting on this particle Q over here. Now you have to ask yourself then that when this Q is moving up the slope, so is it accelerating, is it decelerating, or it's moving with the constant speed? So you have to see that if there are any forces acting on it while it is moving up this slope. So we know that the slope is smooth, so there is no frictional force, but this has got a weight. Okay, so the weight is like this and we have resolved it. So that 4 sine theta is pulling it downwards. There is no upward force. So we like when this motion starts where this string is slack, for that purpose we need to note down that u is going to be 2. That is the speed at which the P reached ground. Okay, it's 2 meters per second. So you have the acceleration. So if it was moving upward under gravity like this, the acceleration would be minus g over here. Okay, but now the acceleration would be okay, no, let's forget that g thing. Let's use that f equal to ma to find that acceleration. Okay, so for this acceleration to be found, we know that there is no upward force, but there is the 4 sine theta, the component of it. There is no upward force, but this 4 sine theta is pulling it downwards. So that is the downward force. This is 4 sine theta, that is 4 into 0.8, that is equal to ma. It's mass is 0.4. So the acceleration is going to be this is going to be minus 0.32 meter per second. No, this is if I cancel this with this is 0.08. Oh, yeah, am I right? Let me use the calculator. Sometimes I really get confused. So you see, I was doing this mentally and I was making silly mistakes. So this is going to be, the acceleration is going to be minus 8 meter per second square. That is for the motion up the slope. Okay, so we have the initial speed 2, the acceleration has been calculated. So this is basically slowing down. So when it reaches the highest position, there we have v equal to 0. So now you can find this distance. Again, using 2as, that is equal to v square minus u square. So you have 2 into minus 8. S has to be calculated. This is 0 and this is minus 2 square, that is 4. So you will get this S is equal to 4 over 16, that is 1 over 4, that is 0.25. Okay, now let me see that what we were required to find. It says find the time taken for the instant that the particles, we have to find the time. Okay, a release from until Q reaches its greatest height. Okay guys, so I have found this distance. Basically we have to find the time. So if you go back to this situation, you have the initial speed, you have the final speed, of the acceleration. So instead of using this, you can use that v is equal to u plus at. So that is going to be 2 equal to 0, and then you have plus 1.6 t. Okay, so you get the time, that is 2 divided by 1.6. This is 1.25. okay, so it's 1.25 seconds taken. And then again, instead of finding this, we have the initial speed with the final speed with acceleration. So again, v is equal to u plus at. Final speed is 0, initial speed is 2, acceleration is minus 8, and the time has to be calculated. So you have the time as 0.25. So the total time taken is going to be 1.5 seconds for this Q to reach its highest position. This is around 1:30 a.m. in the night. So that is why I'm just making these mistakes. Anyhow, through these mistakes you have also learned if the question was to find the distance. So I have done that for you. Okay guys, till the next video, Allah Hafiz.